When we have a carboxylic acid chain that is more than 12 carbons, we no longer call it a carboxylic acid. Instead, we use the name fatty acids. So by definition, fatty acids, these are long carbon chain carboxylic acids that include more than 12 carbons. If you count this example here, it's 15 carbon chain, including, of course, the carbon of the carboxylic acid. This is within the chain in there. So in this case, this is called now a fatty acid. We won't call it a carboxylic acid. We will call a carboxylic acid whenever the number of carbons is less than 12. So 12 or less, this is a carboxylic acid. More than 12, we call it fatty acids in there. Now for fatty acids, they do have a characteristic where they consist of two parts. They consist of a long tail, and that long tail is the hydrophobic chain. We call it the hydrophobic C chain in there. That is the carbon chain. And this is why this is water insoluble. So that one is water insoluble. Okay. And we call this a non-polar tail. And then the second part of the fatty acid is the hydrophobic or hydrophilic head. This is called a hydrophilic, and it is a polar head. Normally the head here interacts with water. This is why we call it water loving, because it can hydrogen bond with water. We know that here on this part we have hydrogen bonding with water, so that can hydrogen bond with water. On the contrary, the C chain in there is completely water insoluble, so that is going to repel water, is going to stay away from the water. This is why we call this part hydrophobic. This part is hydrophilic. Hydrophilic means that it loves water. Hydrophobic means that it hates water. Esters. So esters are another type of functional groups. These are lower priority than carboxylic acid, but still these are higher priorities than aldehydes and ketones. Whenever they are present, you have to end the name in the functional group ester. Okay, the general formula for the ester is the RC double bond O, OR prime. The R's can be either the same or they can be different, doesn't matter. If I want to condense the ester, then I am going to group the oxygens in there, and the condensed form is going to be an RCO2 and an R prime in there. Okay, normally the ester group is this. So this is the carbonyl and the O. This is going to be my ester functional group in there. And then we have a very important bond, which is the weakest bond in the whole ester structure, and that is called the ester linkage bond. Okay, that bond is the bond for reaction. So if you're doing a reaction with the ester, it's this bond that is going to be broken, because this is going to be the weakest bond in there. So let's say if I have this ester in here and I ask you go ahead and draw its condensed form. As we already mentioned, you start reading the molecule always from the left. So you do have a CH3 that is connected to a CH2. I do have 3 of them, so you do have the option either write 3 CH2s or group them together. If you want to group them, then please use the brackets in there or the parentheses. It's very important. And then we have the CO2. This is a C and 2 O's. So I'm just going to write it as a CO2. And then next to it, I do have a CH2, and then I do have a CH3. I may write it like this as well. So if you don't want to group the oxygens, it's fine. 3, then it's going to be a COO, and then a CH2, and then a CH3 in there. So I might also write it as a COO and an R prime in there. Okay. Whenever you want to name the ester, it's always you have to name the part that is connected to the oxygen first. Always. For this example, this is going to be a methyl group. So that is going to be a methyl. Okay. And then after you name the part that is connected with the oxygen, then you go ahead and you name the part that is connected with the carbonyl, including the carbon of the carbonyl. So the rule says that you have to choose the longest carbon chain, including the carbon of the carbonyl. This is naming the rest of the molecules and the rest of the molecule, and you name it as a derivative of the carboxylic acid. So it's as you name the carboxylic acid, imagining that this is an OH, then that is going to be ethanoic acid. In there, you drop the ic acid and you add an AT. So if I want to name this over here, you name it as a derivative of carboxylic acid, making it 2 carbons. So it's going to be ethanoic acid. So what we do is we go ahead and drop the ic acid out, okay? Not the O, the ic acid out, and we replace it by ATE. Esters are always ended with ATE. So the name here is going to be, you start always with the group connected to the oxygen. So the name, the IUPAC name is going to be methyl, okay? Put a space. So it's going to be methyl, you put a space in there, and then the rest of the name ending in ATE. So it's going to be ethanoate. So that's going to be an ethanoate. Okay. Common name. For this one, if I want to name it as a common, then that is going to be acetic acid. So I'm going to drop the ic acid and put an ATE. So the name is going to be methyl acetate. You are responsible to know those. Okay, so let's go ahead and have an example for more complicated esters. So as I said, you always start by naming the part that is connected to the oxygen first. So I know that this one is a phenyl. Okay, and then you name the part that is connected to the oxygen, to the carbonyl in there. So that part in there. You are going to choose the longest carbon chain, including the carbonyl. This is 5 carbons. So instead of naming it as a pentanoic acid, write it down at the beginning so that you can get used to that. So you drop the ic acid and you add an ATE. So the name in this case is going to be phenyl pentanoate. Okay, you're keeping the O in there, so you keep the O and add an ATE. So it's going to be phenyl pentanoate, and of course there is a space between the phenyl and the pentanoate. So there is a space in there. Leave a space, please. Let's have another example. So again, you name the group that is connected to the oxygen first, and the group here is a benzene connected to a carbon. Remember what we said last time? We said that this one is a benz group. It's a substituent, so we're going to call it a benzyl. Okay, so that is going to be a benzyl, and then we are going to name the part, the second part, including the carbonyl. So it's going to be this whole thing in there. And that is going to be butanoate. So it's going to be butane. We drop the oic acid. Okay, so we're going to drop the oic acid out and we're going to add an ATE. So the name here is going to be a benzyl butanoate. Okay. Now, guys, it's very important whenever you are choosing the or naming the carbonyl chain. If there's any substituents here, you also have to take those into consideration. So always, you have to start your numbering from the carbon of the carbonyl and go along the chain. You don't have an option. So the carbonyl always gets carbon number 1, so that if there's any substituent on any of these carbons, you can go ahead and put that on. And when you put the substituent in there, make sure that you put it after the benzyl. It doesn't go before the benzyl. Okay. So let's, for example, see if we have, say, if we have something like this. If we have a here you go, a CH2, an oxygen, a carbonyl, and then a CH2. On that CH2, I have a CH3 in there, and then I have a CH2, and then I have a CH3, okay? And I ask you, go ahead and name this. Then in this case, what you need to do again is number your longer chain. This is 1, 2, 3, and 4. You don't leave the carbonyl behind. You always have to start with the carbonyl and choose the longest carbon chain. So now I have a methyl on the second carbon. So if I want to name this, then it's going to follow the same rules. I'm going to start by naming the group that is connected to the oxygen first, and that is going to be a benzyl. And then I am having a CH3 over here. I'm having a CH3 on the second carbon. So the name here is going to be 2-methyl, leave a space, okay? Leave a space between the benzyl and the rest of the name. So it's going to be 2-methyl. And then 1, 2, 3, and 4, it's going to be butanoate. So the name here is going to be butanoate, okay? This way, you take into consideration every single substituent that is on the chain. Let's have another example here. So we're going to start by naming this group there. This is a, notice, this is now not just a carbon, it's a carbonyl. I did put those two examples under each other because I want you to realize the difference between those two in there. So that is going to be my long carbon chain, and this is going to be my OR substituent in there that I'm going to start my naming with. Okay, so that is going to be the first name in there, which is a propyl, because this one is the one that is connected to the oxygen. So the name in this case is going to be propyl. Okay, let's write it in the black. So that is going to be, and make a, here you go. Okay, so that is going to be propyl. Okay, and then now I want to name the rest of the name. I know that this is a derivative of carboxylic acid. It is a benzoic acid. So we're going to drop the ic acid and add an ATE. So it's going to be benzoate. Okay. Let's have another example here. Notice here we do have a substituent. So we're going to start first by naming the group that is connected to the oxygen. Always, esters, you start by naming the group that is connected to the oxygen. It's a 3 carbons in there. So that is going to be a propyl. And then you go ahead and highlight the group that is on the carbonyl, including that carbonyl. And you give the carbonyl always carbon number 1. It's going to be 2, 3, 4, 5, and 6. You do have a substituent onto, which is the methyl. So the name is going to be 2-methyl. And then, of course, it's going to be hexanoic acid. Drop the ic acid, add ATE. So it's going to be hexanoate. Okay, so that's going to be propyl, 2-methyl hexanoate. Same thing over here. I am naming the group that is connected to the oxygen first, and that is considered to be a benzyl group. This is a benzyl. You have to know the difference between a benzyl group, a phenyl group. So that is going to be a benzyl group there. A phenyl group is just a benzene, no CH2. Then you name it a phenyl. But if there's a CH2 in there, then that is called a benzyl, and then the rest of the name. So for the rest of the name in there, again, including the carbonyl, let's go ahead and highlight that. Always start numbering from the carbon of the carbonyl. It's going to be 1, 2, 3, 4. So the methyl is on 4, 5, 6, and 7. So it's going to be heptanoate. And the name is going to be benzyl. That's going to be benzyl. And then on carbon 4, I do have a methyl and then heptanoate.